Or you.
So, scale 2-3 is over. Someone must have did that in my advisor. Someone touched the camera while out there in the advisor? I didn't. Someone must have touched it, so I didn't touch it.
Was it on or off?
It was on, it was recording. I'll be able to figure it out. Ask Jared.
Yeah, Jared probably back there.
Alright, it is over. No, we're on scale 2-2. Comparing and ordering, right?
Yep.
Comparing and ordering fractions.
Are they doing it?
No, this is the same thing.
Yeah.
Okay? So, yesterday, we talked about what does it mean to compare. Okay? So, what symbols do we use when we compare math objects? Keisha? Greater than, less than, or equal to. Okay? Those are what we call inequality symbols and equation symbol. Alright? Little arrows are called inequality symbols. What are the arrows called? What are the arrows called? Inequality symbols. Okay? You'll be hearing that term quite a bit this year. Alright? So, and how do we read them? Right to left or left to right? Turn around. Turn your feet. There you go. Good. Good. Okay? So, the situations we worked with yesterday looked like what? What did the fractions look like? Okay? It was a specific situation though. What was true about the two fractions? Keisha? The numerators were the same. So say our numerators were 5. What about the denominators? Were they the same yesterday? No. So say this was, I don't know, 18 and this was 21. Okay? How do we compare them? We use inequality symbols. So what are we looking for in this situation? There's a specific thing we did. Remember? Wake up.
Pizza.
We did the pizza, right? Remember, the denominator stands for the total number of slices. Caleb, what does the denominator stand for?
Total number of slices.
Total number of slices. So, how many slices does this pizza have? 18. How many slices does this one have? 21, right? Sam, which slice is going to be bigger? The slice with 18 slices or the slice with 21 slices? Think about it this way. 18, right? Because here's a pizza. It has how many slices?
4.
Here's another pizza. How many slices? 8, right? Which slice is bigger?
4.
The one with 4. So if I take one slice here versus one slice here, who is bigger?
4.
The 4. So who's going to be bigger in this problem? The 18. So 5/18 is greater than 5/21. Okay? You've taken more pizza away. Alright, does that make sense? The smaller denominator is always the larger. Alright, I'll even put a little note down in your notes. When the numerators are the same, the fraction with the smaller denominator is the largest? When the numerators are the same, the fraction with the smaller denominator is the largest. Yes?
I just put in fractions the smallest number is the biggest.
But you got to make sure you say something about these two have to be the same. Because what if they were different? What if this was 4/18? I mean, do you know which one is bigger? So make sure you put, when the numerators are the same, the smaller one is bigger. That will work, okay? Good. All right. So let's just do a couple reviews. See what you do. So copy these down and then put greater than or least than, or equal to. Copy those down and see what you get. Three 15ths, 3/12. Is 3/15 greater than or less than or equal? Which way is the arrow pointing? Less than, so the arrow is pointing this direction?
Yeah.
Is it correct?
Yes.
Okay, good. Patrice. 2/9 or 2/11? Like that way? Why? Why is it like that way?
Because
You got it.
the 11 isn't the like if you like draw it out like a pie, like the 9 would be bigger. The pieces would be bigger.
Good job. That a girl. Get it. Good. We agree? 2/9 is greater than 2/11? Yeah? Kayla! Who's greater?
They're equal.
They're equal. Why?
They're the
They're the same thing. Crazy. Okay, so how does this, so again, we can determine just by looking at them when the numerators are, what do the numerators have to be for us just to say, oh, they have to be the same. Then we can just look at the denominators and decide who is bigger. Okay? Does that help? Okay, so that should help you with your homework. Alright? Today, sunshine, we are going to do a little differently. The numerators aren't going to be the same. So we got to figure out how to do that. And we talked a little bit about that yesterday, right? Okay? Let's see here. Let's say we want to compare this fraction. We're going to do 27 60/3. Oh, whoa. Sorry. Sorry. Okay, let's try this again. 13 27ths versus, no, you wish. 4 21st. Actually, sorry. I get over it. Daddy.
Cheese.
27ths and 4/9. We're going to compare those two numbers. Okay? Now, by just looking at those, can you decide who is bigger than who? By just looking at that, can you decide that?
I guess.
I got it.
You can't just look at this and say, oh, well, this one's bigger than that one, or that one's bigger than this one.
I guess.
It's not possible, okay? What you have to do is, you have to get a common denominator, okay? We find the common denominator by doing least common multiple, okay? Least common multiple. How do we find the least common multiple? We do factor trees. We have 27 and 9.
13 and 4.
Okay. What can I break 27 down into?
3 and 9.
3 and 9? Is that what you're going to say, Caleb? Ben, which one of those is prime? 3 is? What can I break 9 down into? Okay. Now, for least common multiple,
Bigger.
we write the prime factorization. So we do 3 to the third power, right? 3 times 3 times 3 is 3 to the third power. Okay? What can I break 9 down into? 3 and 3. So what's this prime factorization? Somebody besides Easton. 3 squared. Now, is this the large? You take the largest buddy, or you write it once? Least common multiple, you take the largest buddy. So does this 3 have a buddy over here? Yes, 3 and 3. Who's larger? 3 to the third power. Well, what is 3 times 3 times 3? So our least common multiple is 27. With me so far? No? Are you being serious or are you joking? Serious? Okay, so what part aren't you with me with? Where did you get off track?
How do you find the answer?
We haven't got the answer yet. How we did this?
Yeah.
Least common multiple. Okay? We did the factor trees. You good here with the factor trees? Then this is the prime factorization. Remember, you have to write it in its form. Okay? This time, when you find it, you take the buddies, you take the larger of the two buddies. Does this 3 have a buddy over here? Okay, who's larger, 3 to the third or 3 squared? Well, 3 to the third is equal to 27. Does that make sense? Good enough? So, we want our denominators to be 27. Well, Retrice, how do I get 27 to be 27? Do I do anything to it? So this is going to stay the same, right?
Yeah.
But how do I get 9 to be 27?
Don't you multiply it by
Yeah, you got to think, 9 times what gives me 27? 9 times what gives me 27? 3. So I need to multiply this by 3. And what I multiply by the bottom, I need to multiply by the top. So Tyson, what's 4 times 3? 12. So, Kobe, who's bigger?
4 9.
No! Are the denominators the same?
Yeah.
So who do we just look at?
Huh?
If the denominators are the same, who do we look at then? Who's bigger, 13 or 12?
Did you want the smaller one?
Yeah.
Not for this.
Okay. This one's
I know
different.
that's what we just did. Like, that you want the smaller one.
But who's the same here?
Oh,
The
So
numerator.
opposite.
So it's the opposite way.
okay.
Oh,
Does that make sense? Okay. Good, I'm glad you asked that question. It's the opposite of what's here. When you get the denominators the same, it's whoever's bigger, that's the bigger value. So who's bigger, 13 or 12?
13.
So that means 13/27 is greater than 4/9.
I guess it does
Okay? Good? Good there? Okay. Let's try another one. Let's do. Try this one on your own. 11/15 versus.
Read this.
No, silly rabbit.
Tricks are for
5/10.
I like when that one's
17/25. Try those two. Go. We need to find the least common multiple. Alright, so we gotta find the least common multiple to get the common denominators, right? So here's 15, here's 25. What does 15 break down into? 3 and 5. We all agree?
Yep.
Okay? So what's my prime factorization? 3 times 5. That's all it is. What does 25 break down into? What's our prime factorization? 5 squared. Okay, so it's you take the larger buddy. Does this 3 have a buddy? No, so we take him. He's the largest 3, isn't he?
So he's the only 3.
Well, yeah, so he's the largest.
He's the only buddy.
So we have 3. Who's the largest 5?
5 squared.
5 squared. Okay? So now we gotta do 3 times 5 squared. Well, so this is 3 times 5 times 5. What do we get? 75. Okay? This is our LCD, least common denominator. Okay? So this 75 we want to be for the 15 and for the 25.
Over there.
Okay? So that's our LCD. They both going to be 75. Any questions so far? Can you see that, Ben?
Yeah.
Okay? So, what do I need to ask myself? What question do you need to ask yourself? Kobe.
What got you 75?
What?
What got you 75? Like the.
What got me 75? Is that what you're asking me? How did I get 75?
No. Alright.
Are you
I
asking me
did
a
it a
question?
different way, but it gets the same answer.
Did you get 75?
Yeah. Like I just get my denominator and then I take what to 15 and the 75 and I take that times the numerator and that's your denominator.
Okay, so the question I'm asking is, what's my next step to go from here to here? What do I need to do?
Take 75, the 15 and 75 and see what you got, divide that.
So divide 75 by 15. 75 divided by 15. Go ahead and do that.
6.
Whoa! Easy breezy. Is it? One less than 6. 5. Okay? So what do I do with this 5 now?
Take that times
Times 15, right?
Huh?
5 times 15 is going to give me 75.
Yeah.
And when I do to the bottom, I got to do what? So I need to do 11 times 5, right?
Yeah. 55.
This is 55.
So,
What's confusing? Where are you confused?
well, I don't get like how you know if you're supposed to divide or multiply. Like for
Because
the.
You
what?
have to do both.
You have to find out what
So-
15.
So,
Like to get from 25 to 75? Like,
So you're just trying to, you gotta think of what number times 25 is 75. Well, the way to figure out that number is you're doing 75 divided by 25,
so
right?
you always do that?
Yeah, just go ahead and do that. Okay? So, what is 75 divided by 25?
3.
It's 3. So, what do I do with this 3? Explain to me what I do with this 3 up here, Caleb. Nope. What am I trying to do with this 25? What's my goal to do with this 25?
Get it in your center.
Get it to be 75. So what am I going to do with this 3 to that 25 to make it 75? I'm going to times it. Times it by 3. And what I do to the bottom, I must do to the top. Okay? So what's 3 times 17?
51.
51. So, with this case, who is the same?
Denominator.
The denominators. So do I take the smaller numerator to be the bigger one, or the larger numerator to be the bigger one? The larger, so that's greater than that. So that means what? What does this determine?
11/15 is larger than 7.
Is that what you got, Sam?
No.
Okay? So this is why I want to do this then, okay? This works every time. Alright, let's do one. 5/14 versus 35. Oh, I'm trying to think. 12/35. Give that one a shot. Find your least common multiple, go from there.
Okay, do 1435 with factor trees.
I'm doing the factor trees for 1435. What is the purpose of doing these factor trees? What am I trying to find?
LCD.
I'm trying to find the LCD. Okay? I'm trying to find the LCD. So for trees, what does 14 break down into? 7 and 2, or 2 and 7, right? So what's the prime factorization for 14?
2.7.
2 times 7. That's what we call the prime factorization. Okay? Then, what does 35 break down into? 5 and 7. So Ben, what's my prime factorization for 35? Good. We're really good at this part. We're awesome at factor trees. We're the best. Okay, but we got to find the LCD. Okay? So, you take the largest of that number. So 2. We'll start with 2. Who's the largest 2? 2. So I write it. 5. Who's the largest 5? 5. 7. Who's the largest 7?
7.
Are they the same size?
Right.
So you're just going to take one of them. If they're the same size, just take one of them. So 2 times 5 is what? 2 times 5 is 10. Shh. Okay, I'm not. Shh. Okay, gather ourselves. 10 times 7 is what, Tyson? 10 times 7 is what? 70. What is 70? Sam, what is 70? The LCD. So Tyson, what do I want to do now with the 70? It's going to be my numerator or my denominator? The denominator. So here's 70. Here's 70. Alright? So what am I trying to figure out?
The denominator. Numerator.
Okay, not quite. You're not quite. What's my goal? I'm trying to figure out how I get 14 to be 70. So the way I do that is I do 70 divided by 14. Now you can use a calculator for this part. Well, it ends up being 5. Well, what do I do with this 5 now, Ben? What do I do with this 5? I know 70 is divided by 14 is 5. What do I do with that 5 now? Not quite. Patrice?
Don't you times 5 times 5?
Well, before we do 5 times 5, we got to do
5 times
14 times 5. So Ben, when I do this denominator divided by this denominator, I get this number, I'm going to multiply 14 by 5. And when I do to the bottom, I do to the top. So Ben, what's 5 times 5? 25, good. Do you kind of see what we're doing there? Okay. That's what I want to know. I want to make sure you guys get good at this. Alright? Keisha, I got to do 70 divided by 35, right? So,
I'll draw arrows here.
what's 70 divided by 35? 2. So what do I do with this 2, Patrice?
times 35.
And?
And then 12.
Good. 12 times 2?
4.
24.
Now, do I take the larger number or the smaller number to be the biggest? The larger number is the biggest. Okay? So, I'm done, right? Sam, am I done here?
No.
No, what? Who am I really comparing?
14 by 5. 14.
5 14ths and
12 35.
so who is bigger?
5.
5 14.